So this session, we are going to cover the topic of motion under gravity and one-dimensional motion only. Okay, and we'll go through basic theory behind it, and then we'll move on to certain numericals which are typical of this topic. It will cover all important applications. Motion under 1D motion under gravity, two things are important. One, this motion will be only in the vertical direction. The object will move along a vertical line. And second thing, acceleration is constant, which is typically denoted by g. And the value of g is either taken as 9.8, on some cases we take it as 10. So for this session, I will take in all examples value of g as 10, which simplifies calculation so that we can focus more on understanding the basics. And g is again an acceleration, is a vector quantity, hence it has a sense of direction. The direction of g is vertically downwards. We won't say it is positive or negative. Positive or negative depends on choice of axis, but its direction is vertically downwards, or more correctly, its direction is towards the center of Earth. So let's try and understand motion of a stone or any piece, which is any part, small object, which is released from a certain height. It could be from top of a tower. At time t is equal to 0, we release an object, and we want to understand how its motion would be in terms of what would happen to its motion at interval of 1 second each. So how would be after 1 second, 2 second, 3 second. So when we say a particular instance of motion, at each instance, it will have a particular position, it will have a velocity. So what we will try to find out in this case, after 1 second, what is velocity? After 2 seconds, what is velocity? And similarly, what is the displacement or position? Let's get started with this. In this particular case, every time before we start, we need to define the choice of axis. In this particular case, since this in the downward direction, let's choose downward as positive. If I choose downward as positive, see, a value, acceleration direction does not change during its motion. So acceleration will be equal to plus 10 in this case. Acceleration equal to g, and since we are taken downward and g is in the downward direction is plus, let me call this initial position a, and this is at time t is equal to 0. So let's find out what will happen. So at t is equal to 1 second, it will have particular position. Let's see, this is the position, it has a time t is equal to 1 second. That's the point B. At what instance? T is equal to 1. So it will have particular displacement, it will have particular velocity. So we'll not go to spend too much of time to find velocity. It will depend on, we are applying this, we'll apply equation between which 2 points. All 3 equations are applied to 2 different instances of motion. In this case, we'll apply between A and B. First, we'll apply equation V is equal to U plus AT to find out velocity at point B, which will come to 10. And then we can also apply S is equal to UT plus 1 by 2 AT square. So if we apply, let's understand what does this mean here. When I apply between A and B, see, velocity at A becomes initial velocity, and velocity at B becomes final velocity. Okay, and what does S indicate? S indicates displacement from A to B, and T indicates that T is not time. Actually, T indicates time interval. That is the time it takes for object to move from A to B. Okay, so this is why we substitute here. Very easily you can find the S1 will come equal to 5 in this exercise. Okay, similarly we continue here. We take, see, let's say at t is equal to 2 seconds. Again, see, when we come t is equal to 2 seconds, see, now I have choice. I can, to find value at C, either I can choose A as initial point and apply this equation between A and C. And since point B also the velocity and positions are known, I can apply between B and C also. Actually, you can do both. But very typically, we continue with the point which is t is equal to 0 as initial point. So if I apply A between A and C, time interval becomes 2 seconds. Had I taken B and C, had I applied this equation between B and C, then initial velocity will correspond to velocity at B, and time interval will be 1 second. But if I say A and C, t will be 2 seconds. A value will be same irrespective of which 2 points I choose. Okay, so this was just to highlight the important point. Okay, all 3 equations are applied to 2 instances of motion, and this equation involves 3 vector quantities. Actually 4 velocities, acceleration, and displacement, and all 3 have to be substituted with appropriate sign. and sign would depend on what we choose to be positive. So all these vectors which are in the direction of chosen positive direction substitute as positive value, opposite direction substitute as negative value. So that was the only point I just wanted to highlight, because sometimes we miss that small point here. So in this case, again, if I apply whichever way I applied, this will come to 20. And if I have to calculate displacement between A and B, I can use the formula as is equal to this formula, or I have another method also. What is another method? As it moves from A to C, whenever object moves with uniform acceleration, this average velocity is arithmetical mean. That's average velocity. So this velocity here is 0, here it is 20. It means if I take average velocity between A and C, it will come equal to 10. And time taken is 2 seconds. What is this displacement is equal to this also. I could have done using average velocity also, and it would have come equal to S2 is equal to 20. And this method sometimes is useful. And we see some question, this method is much easier and faster, more intuitive. Then t is equal to 3 seconds. Same thing I repeat, is very easy. So this is point A, B, C, D. And again, if I want to calculate what is this distance here, and this is already 20. If I want to calculate only this distance, then I can calculate without S is equal to ut by at square. This velocity is 20. Here it becomes 30. So average is equal to 25. Time interval is 1 second. This distance is 25. This was already 20. So total at 45 meters. So that's how we apply this basic equation. Very simple things. So whatever results we obtain, this S15, S220, and S3 will come total. S3 will come equal to, if I take total displacement from A, S3 will come equal to 45. So ratio of displacements, the ratio of displacement will come equal to 149. And when this is true for which case? This is true for not only in this case, it's true for any uniformly accelerated motion. So A has to be constant, and object should start from rest so that U is 0. So when this becomes 0, it will be very simple. So what is the displacement B equal to in that case? Displacement will be equal to 1 by 2 into A into T square. So naturally, what will happen? Displacement will be proportional to square of the time. So 1, 2, 3, 1 square, 2 square, and 3 square. And even in place of 1, 2, 3 second, if we take T seconds, 2T second, and 3T second also, even then we take the ratio, T will cancel out, the ratio will come same. So this ratio is valid not only for 1, 2, 3 second, it's also valid for T, 2T, and 3T second. There's another term we come across, and this is important to understand. See, something said, what is displacement in 3 seconds? It has a different meaning. That is, displacement in 3 seconds means between time interval of 0 to 3. When we say displacement in third second, this is third second means displacement S3 minus S2. So that is like saying if you are traveling by car, how much distance you have traveled in the third hour. Third hour distance traveled is equal to what? That is total distance traveled in 3 hours minus the distance what you had already traveled in 2 hours. That's the distance traveled in the third hour. So that's the understanding of third hour. So let's apply what is the distance it has fallen in first second and third second, second second and third second. First second is 5, second second is from B to C, and third second start from C and ends at D, which is 25. So if we take this ratio, the ratio comes equal to 1 is to 3 is to 5. Very simple ones. So if we want to express in more general terms, not second and third second, let's say what is displacement in nth second. Displacement in n second, going by the same logic, will be total displacement in n second minus the displacement in n minus 1 second less. Okay, and we can substitute those formula. If it is starting from rest, we can substitute these values. We can get this kind of expression. If it was starting from rest. There's another way we can calculate the displacement in nth second. What is the other way? We use that one, average speed into time interval. If it is nth second, time interval is 1 second. So in that case, what will be the displacement? Average speed. Sorry, average velocity, not average speed. So what is average velocity when we talk about displacement? Bn plus Bn minus 1 by 2. Because in case of uniformly accelerated motion, average velocity is arithmetical mean. That's another expression we can use for calculating displacement in nth second. Okay. Let's move on to the next part. Now this case, earlier we had taken a simpler case when object was falling under gravity, it will move along a vertical line. What will happen if object is projected vertically up? Let's take a simple case. It is projected up with the speed of 30 meters per second. Okay, so in this case, previous case started from rest. Velocity is upward, acceleration is downwards, which you also use the term of retardation. Okay, so what will happen when it will keep slowing down if it is in the opposite direction? It keeps increasing if both are in the same direction. So let me call this point as A, and this corresponds to t is equal to 0. Okay, let's understand how this motion will be at an interval of 1 second each. So this is A. Let's see what will happen after 1 second later. The second later again will have unique position and velocity. Let me call this position as B, and at what instance of time? This is t is equal to 1 second. And if the velocity was 30 in 1 second, it will decrease by 10, as the acceleration is minus 10 here for given this direction. If I take upward direction as positive, it is minus 10. So this will become 20. And if this is 20, what is the distance between the two? Average of the two is 25. So it is at the height of 25 meters. This position is at a height of 25 meters. So this is t is equal to 1 second. Similar way, I can continue to point C, which is at t is equal to 2 seconds. And this will become 10 meters per second. And if we continue for another second more, it comes to point D. But the D point is a little special. What is special about point D? The velocity has become 0. This point, velocity has become 0. So this fairly special point, what is because so far we can take both ways. Since it was moving upwards, velocity was positive. Okay, if velocity be 0 implies what? It is not going further up. So if it is not going further up, this is the highest point. So from here we can also understand what does highest point mean. Highest point mean when the velocity is 0. This implies the velocity has to become 0 at that particular instance. And we also call this position as position of momentary rest. For a moment, velocity is 0. Okay. Even a 1 microsecond before this also velocity was not 0. Even a 1 microsecond later also velocity will not be 0. It will keep changing continuously. Only for instance it is 0, and thus we call this position of momentary rest. Would it stop here? No. We know when you throw the ball, it comes to momentary rest and then you start falling back because acceleration is still acting. The gravitational force is still acting. So what will happen a second later? Second later, now it will start moving downwards. And let's call this point as E. And what instance of time at t is equal to 4. And what with this velocity? Now, downward acceleration, this velocity become 10 in the downward direction. And what is the displacement? Average velocity is 5. So what we notice here, see, between 2 to 3 seconds also, it has moved up by 5 meters. Now it has fallen down by 5 meters. So E and C are nothing but 1 point. We have written 2 alphabets here, but both are one and the same. Okay. So it occupies same position at t is equal to 4 seconds as it was at t is equal to 2 seconds. And this thing will keep repeating. This is very important and simple and important point. So similarly, next second, it was 20, it will become other direction 20. But it will come at exactly same point. So which point? So this is point EF corresponding to t is equal to 5 seconds. And another a second later, it will come to the ground level. And just before it hits the ground, its velocity will be 30. After it hits the ground, yes, ground will exert a force and make it to come to a stop. And this is t is equal to 6 seconds. So let's see what we see in the figure. Can we draw some inferences from here? Can we make certain statements which helps us understand things better? Let's write one by one what we see here. Okay. One thing what we notice, downward motion is identical to upward motion. Only thing is happening in the reverse direction. So if I make a video of upward motion, if I play the video in the reverse direction, it will exactly match with the downward direction. Direction velocity is reversed. So this point I'll elaborate further. We can also say, as it moves from A to D, it passes through every point between A to D twice, except for the point D. Every point it passes twice. So I can say it will pass every position between point of projection and highest point twice. So same thing I can state in some other words. I can say for every value of S, there are 2 values of P and B. So this is also one S. What is this position B? B has a particular position. What is position? 25 meters. This position occupies 2 instances of time, 2 values of T. For B, those values of T are 1 second and 5 seconds. Okay, and we notice here the sum of them is 6. Sum of this also is 6, and so it will occupy given position two values of t, and when it occupies same position, magnitude of velocities are equal, though the direction is opposite. So it will occupy this position once in the upward journey, once in the downward journey. When it is an upward journey, velocity is upwards, and in this case velocity is downwards, but magnitudes are equal. Okay, one thing what we notice here, if we take two positions, B and C, these are two positions. It will pass through the point B and C in the it will travel from B to C in the upward direction, and it will also travel from C to B when it is falling down in the downward direction. And I have C and B are nothing but point E and F. So what time it has taken to travel from B to C in the upward journey, it takes exactly the same time to travel between these 2 points in the downward motion. So we can write this statement: time to travel across 2 points in its path are equal in either direction, or we can say the time to rise equal to time to fall between 2 points. And what we notice here is this is from A to D. What is ascent period? Time during ascent. Time ascent means A to D. Okay, point of projection to highest point. When it is moving ascent, velocity is upwards, acceleration is always downwards, hence it will slow down. So during ascent, as V and A are in the opposite direction, it slows down. It keeps decreasing. Every second velocity magnitude will decrease by 10. What happens during descent? Descent means after it starts falling. Now in that case, descent, velocity and acceleration both are in the same direction. Hence, magnitude of velocity will keep increasing at the rate of 10 per second. I'm assuming G to be 10. If it was 9, 9.8. Important point, sometimes some students make a mistake here very often. So direction of acceleration, whether it's in upward motion or downward motion, direction of acceleration always downwards, regardless of direction of motion, ascent or descent. Okay. Now let's write a few things in general terms. What we have seen in previous case, highest point is a spatial point. So let's try and understand when object with the speed u, and let's take upward direction positive. What is time of ascent? I hope you understand what a time of ascent means. Time it takes to reach the point at the maximum height. So let's say this point was A, and if point B is the highest point, what is special about point B? Velocity at point B will be equal to 0. Okay. So what is time of ascent? Time of ascent is time it takes to reach from A to B. That's the time of ascent. That's the duration for which it keeps going up. So, at this instance, it is at the maximum height. Velocity is 0. It will stop going further up. That's what it means. That's what the highest point means. Velocity becomes 0. So if I apply this equation between these 2 points, between A and B, I have to calculate t value. So I'll calculate v is equal to u plus at, which 2 points I'm applying it. I'm applying between A to B. A is my initial point, and so t indicates time it takes to move from A to B. So if we substitute these values, in this case, upward direction is positive. Hence, since u is upwards, it is taken as positive, but acceleration g is downwards, taken as negative. So we just substitute with sign, we get time of ascent is equal to u by g. Another important term related to highest point is what is the maximum height it will reach. Maximum height is equal to displacement at the instance v is equal to 0. So how do we define? So what is distance from A to B? Again, I apply the equation between A and B. I could have calculated displacement in time t, or I can also use the equation v square is equal to u square plus 2as. This equation we can use for displacement between 2 points if velocity at both points are given, which is the case here. This point also velocity is given, and this point also velocity is implied or given. So okay, so I applied this equation between 2 point A and B, and A value I substitute at minus g. So if I substitute those values, v is equal to 0 and so on and so forth, I find the maximum height is equal to u squared by 2g. And this is a very simple and very commonly used equation and formula which you should remember. Okay. Let's apply this in some simple cases. Let's come back to the previous question what we had done. See, what is this here? So we had done something. I'll just write what is this was at t is equal to 0. We were at point A. At t is equal to 1 second. This was t is equal to 1. This was t is equal to 2. This was t is equal to 3. This was t is equal to 4. And this was t is equal to 5. And this was t is equal to 6. Right. So what is displacement in 1 second? And this was again 30 meter per second. We have already calculated, which is pretty easy. That's a displacement in 1 second. Displacement in 1 second, this speed will be 20. And this came to 25 meter. This is easy. I could have calculated displacement using S is equal to UP plus 1 by 2 AT square, applying this equation between 2 point A and B. Okay, displacement in 5 seconds. When you look at this point, where is it? This object is at the same position. So some of you might be tempted that displacement at 5 seconds will be different. No, it has come back to the same position. It depends on the position only. So displacement is this position minus the initial position. So displacement in 5 seconds means position at 5 second and position at 0 second. So this is a displacement which is same as before. So displacement in 1 second and displacement in 5 seconds are equal because positions are equal. But more I ask, what is distance traveled in 5 seconds? Distance traveled in 5 seconds is not 25 meters. Because to know distance traveled, you have to take the path length. So how it has moved, it has, so you calculate distance traveled in 5 seconds will be equal to A to B, C, D, E, F. So can we write what is distance traveled in terms of this alphabets? Distance traveled will be equal to A to D plus D to F. Okay, that's the distance travel. So distance travel, so what is this an important part what we have to understand? Distance travel and displacement magnitude are equal till the time the motion is unidirectional. As long as keep moving the straight path in the same direction, both values are same, which is the case from A to D. So between time t is equal to 0 second to t is equal to 3 second, if I calculate distance travel and displacement, both will come equal. But for any value of time greater than 3, because 3 seconds, it changes direction. So what happens after 3 seconds? Distance travel will keep increasing, but displacement starts decreasing because it started moving towards the initial point. So at t is equal to 3, now what happens? Displacement magnitude becomes less than that. So what we observe here, we can also write is, if time t is greater than time of ascent is the time it takes for it to reverse its direction, or time when it comes to momentary rest, then distance traveled is more than displacement. So I can write like this, okay, or you can also like this, what is d to f equal to? This is point, d to f I can also write, it is equal to a to d. I can write d to f also is equal to, what is d to f equal to? That also is equal to a to d minus fg is equal to a to d minus fg. What is fg? Fg is the displacement. So I can write what is this a to d twice. A to d is nothing but h max. So I can return this one 2 into h max minus fg. Fg is the displacement in 5 seconds. So that's why I could have written 2hm minus st. That's a distance travel in case of t exceeds time of ascent, or the time involves reversal of direction. Time is more than time it takes for it to come to momentary rest. Any of the three methods, I can say the same thing. Now look at some more numerical. Okay. And these are application of what we have done before, simple application. Body is thrown vertically up from the ground with the speed u, and it reaches a maximum height h at time t naught. What is the height to which it would have risen at time t is equal to t naught by 2 in terms of h? So before we start solving, let's try get a mental picture or make a simple diagram. This is the initial this is the ground. From here it is projected. I have taken upward direction to be positive, and it reaches a point. It reaches maximum height. So this is a point. This is the maximum height. At what time it reaches? So time is given here. Time is t naught. Another thing, though it is not given, the word maximum height used itself indicates what is implied here. At that particular point, velocity is 0. So let me call this point as A and this point as B. This is what is given. Is height is given, displacement is given, velocity is given, time is given. And we know what are the values here. What is h equal to? H, I could write h also in terms of u. H is equal to u square by 2g, what we had done before, maximum height. And what is t naught? T naught is nothing but time of ascent, which is equal to u by g. Okay. What we need to find here? We need to find, during its upward motion, it would pass through some point C at time t naught by 2. So what we need to find, what is this height of C? What is A to C displacement? Or other words, what we need to find here, we need to find displacement S at time t is equal to t naught by 2. So what is the standard method? One method, okay, I can apply displacement. I have to calculate displacement between A and C. So which formula at time t naught by 2? So I have to have S value and time value. So which formula I'll use, which has displacement and time? I'll use formula. I could use formula S is equal to ut plus 1 by 2 at square. Which 2 points I'll apply it for? I'll apply between point A and C. Okay. So what is u value here? U is given. It is positive value. T is equal to is t naught by 2. And A is equal to, we need to understand A is equal to minus G here. A is negative. I have taken upward direction positive. That's why U is taken as positive. So I could calculate. So what do you get here? So this S will come as H dash. H dash will go U into T naught by 2. And since G is minus, I take minus sign out. It is equal to minus G by 2 into square of the time, which is T naught by 2 square. Okay. So what you get here, I want to get the answer in terms of H, but it's coming in terms of T naught. Plus in place of T naught, I can substitute U by G. So I can substitute T naught in terms of U by G. And then finally what will happen? I'll substitute U square by 2G is equal to H. So these two substitutions I'll make in this equation and I can find the value of H dash. That's one method of solving. Can we think of some other method? What you notice here, this time is T naught. It means time from C to B also is T naught by 2, equal time intervals. So can we think of some other method also to solve? So let's look at alternate method. This is one method. This is standard step by step. And it's a very simple, but it's a formula. Second method, let me use second method. So suppose I restate this question, see whether this statement is same as previous one or not. And so after, so I have just reversed the direction. We have seen that the upward motion, downward motion is reverse of upward motion. So rather than object going up, I'm taking the object falling. A body falls from rest from height h. At t0, it starts falling from this height. What height? Same height h. Okay. And it falls how much height? It falls by this height h. And how much time it will take to fall? It will take time t naught. So whatever time it has taken to go up, it will take same time to fall. Then find the distance it would have fallen in time t naught by 2. So can we find this distance here? How much distance it will fall in time t naught by 2? This is extremely easy to solve. What we find here, this time compared to for time t naught is half of this time. If the time is half, the displacement will be 1/4. So this is h. From here to here, this will be equal to h by 4. And hence from here to here, the distance will be equal to 3h by 4. Okay. So this t naught by 2, and this time, this is twice the time. The ratio of displacement in time t and 2t, whatever time and twice of the time is equal to 1:4. I could have done that also. Compared to this distance is 1/4, or distance is 1/4 of the distance h. So if this is h by 4, this is 3h by 4. No calculation, very quickly could have solved. We should know the alternate approaches as well. Okay, let's look at the next question. Okay, ball is thrown vertically up with certain velocity from the top of a tower. So just visualize you're standing the tower. You're just throwing from the side of the tower so that it can fall back also. And what is the height of the tower? Is 40 meters. And this is my ground level. Okay. And what is given here? At 4.5 meter above the top of the tower, its speed is exactly of half of it will have at 4.5 meter below. So it is concerned about two specific position of its object. What are two specific positions? Let's draw a figure and try to understand. The first point is 4.5 meter above. Second is 4.5 meter below. It relates to velocities. So let's draw a figure and understand. So in this case, let me take a coordinate system. Upward direction is positive, and this is my reference level. So this is how the object will move. It will reach a highest point and then start fall and will reach the ground. It will pass through all the points which are indicated here, right? So which are the points we are interested in here? This is the initial point A. Another point B, let me call this, let put as H. What is H value? How high this point is? H is equal to 4.5 meter. And this particular point, it will be certain, it will reach at certain instance of time, and it will have particular velocity. Let me call this velocity is V1. And what is second point? It is half of the, exactly half of that it will have at 4.5 meter below the top of the tower. So from here, 4.5 meter below. That's the next point. So this A, B, C is the highest point, and D is the point which is from here, again, how much below? H, same H, which is equal to 4.5. I'll put initially everything in terms of variable, which makes things easier. And that's the right method to solve. What we need to find here, this is what is information given. And this point velocity is V2. What is here is half. So V1 is what is given. V1 is equal to V2 by 2. Is half of that velocity. What we need to find? We need to find the maximum height. And maximum height we know already. What is maximum height equal to? So to find, we have to find maximum height. And if I assume this velocity to be u, maximum height h max is equal to u square by 2g. So I have to find value of u square by 2g. And so basically what I need to do to get the value of u square, I have to relate this velocity u in terms of this h value. Then only I can find h is a constant. How do I do that? Okay. So in this case, two velocities are given. So what I do, I need to form equation between v1 and v2. How to form equation between V1 and V2? I can apply equation of motion between 2 points B and D. That's one method. So apply. So which 2 points we choose? B and D. So B is my initial point and D is my final point. Which formula should I use here? Okay, between B and D, displacement is given. So important point is, what is displacement from B? Yes, given. What is displacement? So which is the initial point? B is the initial point and D is the final point. So when we talk about displacement, displacement is a vector. So I'll draw tail of the vector at the initial point. This is my displacement. This is the arrow, indicates displacement. Displacement is 2h in the downward direction. So I write displacement is equal to minus 2h. So this point is important. If you don't understand, or minus 9 meters. Just a displacement. So displacement and velocities, which is the equation I should use, which are displacement and velocity? Let's use the equation, very obvious. We'll use the equation b square is equal to u square plus 2as. Let's substitute values one by one. B, anyway it is squared, so it doesn't matter which sign, though value is negative v2. V square is equal to velocity at d, which is v2 square. Initial velocity v1 is square. Since they are square, it doesn't matter what the sign is. A value is minus g. Understand? A is equal, so I'm taking minus, so plus 2 into minus g. And what is displacement? Displacement is also equal to minus 2h. So what do you get this one? So this is the important one. And then we substitute what is v2 equal to. V2 is equal to 2v1. So I'll substitute 2v1 square v1 square plus 4gh. Okay. So we can find value of v1. And once you have what is value of v1 you get here? Four v1 square is equal to v1 square plus 4gh, or v1 square is equal to what? 3v1 square is equal to, this is 4gh1 by 3. And so what is, if I take v1 square by 2g, what is left? 2g I have taken, 2h1 by 3 is left. So 2h by 3, no h1 here, 2h by 3. And what is 2h by 3? I can substitute the h also. H is 1.5. H is equal to 1.5. So what do we get here? 1 meter. What is v1 square by 2g mean? V square by 2g means from this point, from B it will rise B to C. It will rise by a distance of 1 meter. From here to here, this distance is 1 meter. That's what it means. So what is the total height it will reach? Maximum height it will reach above the ground. Maximum height reached by the ball above the ground. This is 1 meter. This is 4.5 meter. This is 40 meter. So maximum height, what is the height of point C? This is 1 meter. From here to here, 4.5 meter. And this one is 40 meter. So maximum height reached will be equal to 45.5 meter. So maximum height from the ground. Had they asked the question, what is maximum height above the top of the tower? Answer would have been 5.5 meter. And so this important point, wherever the velocity is given, v square by 2g indicates the further height it will reach, further maximum height will reach with respect to that point. So that is the important point. This is something all of you need to understand here. Okay. Next question. Okay, whatever information is given, read the question. I will draw a figure of whatever is given here. From the top of tower, the stone is thrown up and reaches the ground in 1 second. Okay. In this case, all cases reaching the ground, displacement negative. So displacement is in the downward direction. So I will take downward direction to be positive. Okay. This first stone, it is thrown up. Let's say it's thrown up with the speed u. It reaches ground time t1. So it will go up and fall back. This one hits the ground at what time? It hits the ground at time t1. Okay. Second stone is thrown down with the same speed. So if this was u up, this is u down. And if this was taken, this I'm sure this you can understand t1 would have taken more time. Here it again it reaches the ground in time t2. Third case, what is given? A third stone released from rest reaches the ground in time t3. Okay, this is the third stone. This is released. Release means u is equal to 0. Initial velocity is 0. So this is first stone, second stone, and third stone. And this reaches the ground in time t3. Let's say height of the tower is h. So all of them have same displacement. One in time t1, other is in t2, and other in third in t3. So that's the condition we have to use. What we need to do, we need to find the value of t3 in terms of t1 and t2. Okay, so that's what we need to do. So, so what we'll do here, we can write this equation for all three stones. The first stone, what are all cases, what we have to make use of here, all of them have same displacement. Time is different, initial velocities are different. So we'll write equation which has a displacement and time, and which direction taken downward positive. So all cases acceleration will be equal to plus v. All displacement also, all will have equal displacement. All displacement will be equal to plus h. So let's write all cases, which equation we are using equation s is equal to ut plus 1 by 2 at square. I hope the reason also is clear. The first one, s is all cases positive, s is okay. But just be careful. First case, time interval is t1, but u is upwards, whereas downward direction is positive. So u is negative. In first case, I'll substitute u is equal to minus u, and time is t1. And here, downward is positive, so g is already written, acceleration is positive, plus 1 by 2 g t1 square. Similarly, I write for second stone, h will be equal to, in this case, u is positive. That's the only difference between the two. And time is t2. U t2. And acceleration, all three cases, downwards, hence positive. t2 square. That's the second equation. And for third stone, initial velocity is 0. So h will be equal to 1 by 2 g t3 square. I have to find value of t3 in terms of t1 and t2, but it's given in form of h. Okay, so what I need to do, I need to substitute h in form of t1 and t2. But in both the cases, when you look at the h term, in addition to t1 and t2, it also has a u term. So what I need to do, I need to find a relation between h and time without u term. So what I need to do from equation 1 and 2, to solve this equation, I have to eliminate u from first and second equation. So I have to write the equation eliminate. How do you eliminate? One way of eliminating this would be if I multiply, make this, both are sign opposite. Okay, both have opposite sign. So I can eliminate if I make the coefficients equal and add it up. So if I multiply the first one by T2 and second one by T1 and then add those two equations. So if I add those two, left hand side will become equal to H into T1 plus T2. Right hand side, this term will cancel. And if you just notice 1 by 2 G T1 T2 will become common. And what will left is T1 plus T2. This is I have missed one step, but this is a pretty simple one. So it gives you value of H is equal to 1 by 2 G T1 plus T2. That's what we wanted. Now we can substitute in this equation. So substitute in third equation. So 1 by 2 G T1 T2 is equal to 1 by 2 G T3 square, which gives me T3 is equal to, in terms of T1 and T2, is equal to root of T1 T2. Okay, next question. All of you can pause the video and read the question. I'll quickly draw the figure here. It's shown it projected upward with the velocity u. So I'll just draw a figure. It is projected with velocity u. And of course, it will go up, reach a maximum height, momentary rest, and again fall back to the same point. So, but during its journey, it passes through 2 points. So let's mark those 2 points. As it keeps going up, velocity keeps decreasing. From u, it has become u by 2, point P. Then it passes to another point Q, velocity has become u by 3. That's what is given here. And what else is given? This point P and Q are separated by height h. So distance between those 2 points is h. Find the maximum height the stone will reach. Okay. So the method is, I think in this case, is fairly simple. What is the method here? I want to find maximum height. And maximum height is equal to u square by 2g. If I have to find maximum height here, in terms of actually the options given were in terms of h. So what I need to do to find this u, I need to express u in terms of h. So I have to find the equation between u value and h value. So find or express u in terms of h using some information given in the question. Because u and h are related in terms of h. So how do we find relationship between the two? Since these 2 point distance is given, I can apply equation of motion between P and Q. So I'll use equation, apply which 2 point? Apply equation of motion to P and Q. P is the initial one and Q is the final one. Okay, that's the one which comes in the time sequence which comes first. That's the first one and the second one. So which equation do I apply? Distance is given, velocities are given. So displacement is given between P and Q. Displacement is h from P to Q. What is the direction of displacement? This is displacement. If I take P as initial point, this is the including indication of direction. Displacement is plus as per this convention. So here S is given as h. So I'll use equation V square is equal to U square plus 2as. What is V? Velocity at point Q. Let's just put the value u by 3 whole square is equal to u by 2 whole square. And how about acceleration? Since I have taken upward direction positive, this acceleration will come negative. So this minus 2 into g, and displacement is plus h. That's only minus sign because of this being negative, this is positive. So what do we get here? U square by, I have to get u square by 2g. Okay, so I'll always keep in mind what we need to find. U square by 9 is equal to u square by 4 minus 2gh. So if I take this to this inside, 2gh is equal to what? 2gh becomes equal to u square 1 by 4 minus 1 by 9, which is equal to 5u square by 36. So what is u square equal to? 72 gh by 5, or u square by 2g. I divide by 2g, it becomes 36 h by 5. That's the answer. That's maximum height from here. So if I reach the maximum height here, what is the value? 36 h by 5. That's the answer. Next, a stone is thrown vertically upward with initial velocity u. The distance traveled, first thing we need to notice here is not asking for displacement. We need to understand this the difference between displacement and distance traveled. In time 4u by 3g. If you recall, initially also we have this point I have given special attention. These two are equal until it keeps moving to the top point. So this time, does it corresponds to more than time of ascent or less than time of ascent? Time of ascent, time to reach the highest point. Let me mark this point as A. So does this point lie in the upward journey or does it lie in the downward journey? If it is lying in the downward journey, I have to use a different method slightly. And here we will notice very easily, time of ascent here is what? Time it takes to point, time of ascent means time to reach B is equal to U by G. Whereas this T is greater than time of ascent. It means it has reverse direction. I cannot use displacement formula. Some of you, when you look at the method, some of you may get tempted. Okay, pretty simple. In this is the time given. I can use formula. Time is given. Initial velocity is given. So I can use formula S is equal to ut plus 1 by 2 at square with appropriate sign. If I take upward direction positive, I can calculate S is equal to U is positive U into 4u by 3g, and g will be negative, acceleration is negative because I have taken upward direction positive, minus 1 by 2 g into square it 16u square by 9g square. And now how much this comes to? And this comes to u square by g term, and what is left here is 4 by 3, and this is minus 8 by 9. This one g gets cancelled. And what is that equal to? U square by g. You multiply with 3 and 3. So 12 minus 8, 4 by 9. Is this the distance traveled? No. This value is what? This value gives you displacement at this instance of time. So it has gone up. If C corresponds to T is equal to 4u by 3g. This value gives you displacement. It gives you this value. That's not the distance traveled. So we have seen earlier, what is the distance traveled? One way of telling the distance traveled will be, so if I have to calculate distance traveled, from there it's pretty simple. Distance traveled will be equal to AB plus BC. Okay, so what is AB equal to AB plus BC? So what is AB here? I can calculate AB. AB is equal to U square by 2G. And what is BC then? BC is equal to AB minus S. So I could have written, as I mentioned earlier also, it can be written as maximum height, which is AB, plus maximum height minus displacement, which we have calculated here. Or it can be written as twice the maximum height minus the displacement, which will equal to U square by G, twice the maximum height, minus the displacement is equal to 4u square by 9g, which comes equal to 5u square by 9g. So that was a important point, what you need to understand. Difference between displacement and distance traveled. This is a good example to understand the difference between the two. Okay. Okay, let's look at the last question in this session. Ball is dropped from the roof of a tower of height h. This is a tower of height h. The total distance covered by it in last second of its motion is equal to distance covered by it in first 3 seconds. What is the value of height h in meters? So if you have to represent in figures, this is a tower of height h. The ball is dropped from the top of the tower. This is corresponding to t is equal to 3 seconds. Okay, so this is it takes to, let's say, so how much time does it take to hit the ground? T second. So what is the distance? What is the point corresponding to what is last second? The last second is displacement between t minus 1 and t. So this is the position corresponding to t minus 1 second. This is 1. This distance, what it says, is equal to what? is equal to distance covered by in first 3 seconds. So if I take next point here, 3 seconds, these two distances are equal. So if I have to write in terms of equation, how would I write? Displacement in 3 seconds is S3 is equal to ST minus 1. And we have seen earlier also what is ST minus 1. I can easily calculate those one and equate. Okay, so that's a method. Method in terms of method is fairly simple. Equate those two. So what is S3 is equal to ST minus 1. We have just assumed T is the time to hit the ground. Okay, T is the total time taken. T is total time in seconds. Total time of motion. Let's put this value. So what is that will be equal if we take downwards, it will all be positive 1 by 2 G into 3 square will be equal to 1 by 2 G. First one will be T square minus 1 by 2 G into T minus 1 square. Okay, and if we simplify, we get the value of 1 by 2 G gets cancelled. 9 is equal to 2T minus 1, A square minus B square, or T is equal to 5 seconds. How much time does it take to hit the ground? It takes 5 seconds. So what is the value of height? So H will be equal to distance traveled in 5 seconds. Thus H equal to, what is that will be equal to 1 by 2 G into 25. That's your answer. Okay, so that's what we just wanted to cover in this session. So I'll end it here. So go through every part and see that is well understood. Thank you.